here. The number of circular permutations of n dissimilar things the number of circular permutations of n dissimilar things taking r at a time. Taking the number of circular permutations of n dissimilar things taken r at a time. Taking r at a time is clearly NPR by R. The number of circular permutations of n dissimilar things. The number of circular permutations of n dissimilar things taking r at a time. Already we discussed what here, that is the number of circular permutations of n dissimilar things taking n at a time. That is all at a time is clearly n minus 1 factorial. Here the number of circular permutations of n dissimilar things taking r at a time is how much? NPR by r. Solution proof, that is, let us assume that number of circular permutations. Let us assume that number of circular permutations of n dissimilar things. Number of circular permutations of n dissimilar things taking r at a time. Is equals to, that is K. So, circular permutation, in this case, circular permutation, consider one circular permutation, that is clearly first, second, third, fourth, fifth, and so on. Arc lines. There this is A1, A2, A3, A4, A5. This is the arc lines. Consider these one of the k circular permutation, one circular permutation taking r at a time. This circular permutation, already we discussed. This circular permutation gives rise to r linear permutations. This circular let's take one circular permutation. One circular permutation. This circular permutation gives rise to r linear permutations. One circular permutation gives rise to, if you disconnect this circle, we get A1, A2, A3 and so on AR. Here we disconnect with A2, A3 and so on AR. If you disconnect here, means we get how many linear permutations we get, means clearly R linear permutations we get. Every disconnecting point we get, how many disconnecting point means we get R disconnecting points. So R makes this disconnect this circle. So we get R linear permutations we get. So every circular permutation gives rise to R linear permutations. Every circular permutation gives rise to R linear permutations. We have k circular permutations. So k circular permutations shows k circular permutations gives rise to k into r linear permutations. K into r linear permutations. So according to problem, we know that we know that number of linear permutations of n dissimilar things taking R at a time is clearly NPR. The number of linear permutations of n dissimilar things taking R at a time is clearly NPR. According to problem, K into R is equals to NPR. K into R is equals to NPR. We want K, so K is equals to NPR by R. K is equals to how much? NPR by R. So this is the theorem, that is the number of circular permutations of n dissimilar things. The number of circular permutations of n dissimilar things taking R at a time. Taking R at a time is clearly NPR by R. NPR by R. The number of circular permutations of n dissimilar things taking n at a time, that is NPN by n. That is n factorial by n. We get n minus 1 factorial. So like that only, the number of circular permutations of n dissimilar things taking R at a time is clearly NPR by R. NPR by R means, how to get this proof means, let us assume that number of circular permutations is equals to K. Number of circular permutations is equals to how much? K. So every circular permutation gives rise to R linear permutations. Every circular permutation, if you disconnect, how many ways to disconnect this circle means, we have R blank places, so R ways to disconnect this circle. So that's why every circular permutation gives rise to R linear permutations. Every circular permutation gives rise to R linear permutations. We have K circular permutations. So K circular permutations gives rise to K into R linear permutations. K into R linear permutations. Already we know that the number of linear permutations of n dissimilar things taking R at a time is clearly NPR. NPR. So that K times of R is same as NPR. So we want K value. K is equals to NPR by R. NPR by R. This is the next. Yes. Already completed one theorem. That is the number of circular permutations of n different things taken R at a time. The number of circular permutations of n different things taken R at a time is clearly, that is NPR by the number of circular permutations. The number of circular permutations of n different things and dissimilar things taken R at a time. R at a time is clearly NPR by R. The number of circular permutations of n different things or n dissimilar things taken R at a time. Taken R at a time is formula is already discussed in previous theorem, that is NPR by R. Let us discuss one example here by using this formula. One example. Find the number of circular permutations of number of circular permutations. Find the number of circular permutations of 10 boys, or take 7 boys, sit around a circle. Sit around a circle, taken 5 at a time. Taken 5 at a time. 5 at a time. Solution observe here. Find the number of circular permutations. We want to find the number of circular permutations. 7 boys sit around a circle, taken 5 at a time, 5 at a time, 5 members at a time, 5 members at a time. So we want number of circular permutations. Already we discussed one theorem, that is the number of circular permutations of n dissimilar things. The number of circular permutations of n dissimilar things taken r at a time, clearly npr by r. npr by r. The number of circular permutations of n dissimilar things taken all at a time, already we discussed one theorem, that is n minus 1 factorial. N minus 1 factorial. Here we use this formula, that is npr by r. So here clearly n is equals to total 7 boys. Number of boys is equals to 7. So n is equals to 7 taken 5 at a time. That means clearly r is equals to 5. R is equals to how much? 5. Already we use this formula, that is the formula is np r by r. Number of arrangements. Number of arrangements is equals to npr by r. Clearly npr by r. Here n value 7, p5 by 5. npr, already we know that npr means n factorial by n minus r factorial, that is 7 factorial by 7 minus 2 factorial into 1. That is 7 minus 2, 7 minus 5. So r value how much? 5. So 7 minus 5 factorial into 1. That is 7 factorial by 7 minus 5 factorial, nothing but 2 factorial into 1 by 5. 2 factorial into 1 by 5. That is 7 factorial means 1 into 2 into 3 into 4 into 5 into 6 into 7 by 2 factorial means 2 only into 5. That is 5 and 5 get cancelled, 2 and 2 get cancelled. 3 4 12, 12 6 jar 72, 72 into 7, clearly 72 is 40, 7 7 is 49, 49 plus 1, 50, that is 504, that is 504. Therefore, the number of circular permutations of 7 boys sit around a circle taken 5 at a time. Taken 5 at a time is how? That is number of arrangements is 504. 504. Here, the number of circular permutations of n dissimilar things taken all at a time is formula npr by r. The number of circular permutations of n dissimilar things taken all at a time is npr by r. The number of circular permutations of n different things taken all at a time is clearly n minus 1 factorial. Yes. Next formula, that is the number of circular permutations. The number of circular permutations of n different things the number of circular permutations of n different things taken r at a time in one direction is in one direction. That means in case of garlands of flowers, necklace of beads, you can take only one direction. So in that case, the number of circular permutations of n different things taken r at a time in one direction is clearly, that is npr by 2r. npr by 2r. Already we discussed before, that is the number of circular permutations of n different things taken all at a time in one direction. In one direction is clearly half of the n minus 1 factorial. That is n minus 1 factorial by 2. In special cases, that is beads of necklace or flowers, garlands of flowers, like that cases, we consider only one direction. In that cases, only considered as one direction. In that cases, we use this form, NPR by 2R. NPR by 2R. Let us discuss one example here. One example. In how many ways? In how many ways can seven different color beads be strung? In how many ways can seven different colored beads be strung and a necklace on a necklace? Observe here. In how many ways can seven different colored beads be strung on a necklace? First one, taken 5 at a time. The second one, taken all at a time. In how many ways can seven different colored beads be strung on a necklace? That is taken 5 at a time and taken all at a time. Taken 5 at a time and taken all at a time. We know that this is necklace. In necklace, we consider only one direction. So, first one, the formula is the number of ways arranging taken 5 at a time is first one. This is first one. Taken 5 at a time. So the number of ways arranging taken 5 at a time means clearly this is a necklace of beads. So consider as only one direction. Already we discussed the formula. The number of circular permutations of n different things taken r at a time. The number of circular permutations of n different things taken r at a time. In one direction is NPR by 2R. So that is NPR by 2R. Here n is equals to clearly, they gave n is equals to 7 and r is equals to 5. N is equals to 7, r is equals to 5. Therefore, number of ways is equals to 7p5 by 2 into 5. So NPR by 2R in one direction. So that's why that is 7p5. 7p5 is nothing but 7 factorial by 7 minus 5 factorial into, that is 1 by 10. So that is 7 factorial means 1 into 2 into 3 into 4 into 5 into 6 into 7 by 7 minus 5 clearly 2 factorial. 2 factorial is nothing but 2 only. 2 into 10. So 5 ones are 5 2s, 2 ones, 2 get cancelled, 2 ones are 2 2s. So 3 2s are 6, 36, 7 36 into 7, 6 are 42, nearly 4 into 7 3s are 21 plus 4, nearly 250. So number of arrangement is equal to how much? 250. So observe here, in how many ways can 7 different colored beads? In how many ways can 7 different colored beads be strung on a necklace? Taken 5 at a time. So number of circular permutations is equal to, already we know that the number of circular permutations of n different things taken r at a time in one direction. Is NPR by 2R. By using this formula, clearly n is equals to 7 and r is equals to taken 5 at a time. So r value 5. Substitute here, we get NPR by 2R, we get 252 arrangements. Next, here we give another question, that is taken all at a time. Taken all at a time means Already we know that is taken all at time. Already we discussed one formula, that is the number of circular permutations of n different things taken all at a time. The number of circular permutations of n different things taken all at a time in one direction. In one direction is half of n minus 1 factorial. The number of circular permutations. The number of circular permutations of n different things. The number of circular permutations of n different things taken all at a time. Taken all at a time in one direction. In one direction is clearly we know that is half of n minus 1 factor. Half of n minus 1 factor. Half of n minus 1 factor. Clearly taken all at a time. All at a time means they gave n value 7. So clearly half of 7 minus 1 factorial, that is half of clearly 6. So the number of arrangements is equal to half of 6 factorial. Already we know that 6 factorial means 2 3s are 6, 6 4s 24, 24 5s 24 into 5, 24 into 5, 5 4s 20, 5 2s 10, 120 into 6, clearly 720. So 720 by 2, 2 3s are 6, 2 6s are 12, and so 360. Number of arrangements is equal here 360. Observe. Very important formulas, 2 formulas. Special cases, that is the garlands of flowers and beads of necklace. We consider only one direction. In that special cases, we use the number of circular permutations of n different things taken all at a time. The number of circular permutations of n different things taken all at a time in one direction. Consider as one direction. So that's why formula is NPR by 2R. NPR by 2R. The number of circular permutations of n different things taken all at a time is clearly half of n minus 1 factor. Half of n minus 1 factor. This is concept. So let us discuss problems on this concept. Yes, in circular permutations, about the concept we discuss some problems here. Observe here. In how many ways can 5 men sit around a round table so that all shall not have the same neighbors in any two arrangements is? In how many ways can 5 men's number of men's is equals to clearly, so Hessian number of men is equals to how much? So in how many ways can 5 men sit around? Sit around means we want number of circular permutations we want. Sit around a round table. Sit around a round table means we want number of circular permutations so that all shall not have same neighbors. Observe here. So that all shall not have same neighbors. That means here we consider only single directions. If you take both directions, that is clockwise direction and anti-clockwise direction, they come same neighbors. So here they give all shall not have the same neighbors. All shall not have the same neighbors means we consider only one direction. So the number of circular permutation. The number of circular permutations, n different things, taken all at a time in one direction, in one direction is equals to half of n minus 1 factor. Half of n minus 1 factor. That is equals to number of ways is equals to number of ways is equals to. You know how many ways can 5 men sit around a round table so that all shall not have the same neighbors. All shall not have the same neighbors means we consider only one directions. That is clockwise or anti-clockwise direction. We consider only one direction. We use this formula, that is half of n minus 1 factorial. Half of n minus 1 factorial. That is equals to number of ways is equals to half of n and here 5 minus 1 factorial. Half of 5 minus 1 factorial. That is equals to half of 4 factorial. Already we know that 4 factorial value, 4 3 is 12, 12 2 is 24. That is equals to 24 by 2. That is equals to number of ways is equals to how many ways? 12 ways. Clearly 12 ways. Observe here. Round table means circular. We want circular permutations shall not have the same neighbors. Shall not have the same neighbors means they ask only one direction. One direction circular permutation they ask. So that is formula is half of n minus 1 factorial. Half of 5 minus 1 factorial. 5 minus 1 factorial is nothing but 4 factorial. 4 factorial value clearly 24. 24 by 2, that is equals 12 ways. 4 3 is 12, 12 2 is 24. 4 factorial means. Next, observe the second question. The number of ways of arranging 8 men. The number of ways of arranging 8 men and 4 women, 8 men and 4 women around a circular table such that no 2 women can sit together is. No 2 men can sit together is. Clearly, number of men is equals to number of men is equals to clearly 8. Number of women is equals to 4. Here they ask circular permutations. Clearly around a circle, that means circular permutations, and they gave one condition such that no 2 women can sit together is. No 2 women can sit together is. First of all, we arrange 8 men in a round table, that is really M1, M2, M3, M4, M5, M6, M7, M8. So clearly, the number of ways of arranging 8 men, 8 men and 4 women, 8 men and 4 women. So 8 men, first of all, we arrange the circular permutations 8 men. 8 men, how many ways to arrange the 8 men in your circular permutations means clearly we know that 8 minus 1 factorial. 8 minus 1 factorial. In how many ways arranging 8 men? 8 men in around a circle clearly 8 minus 1 factorial. 8 minus 1 factorial. Next, 4 women are around a circular table such that no 2 women can sit together is. No 2 men can sit together is. Clearly, women are arranged these gaps only. So how many gaps first of all here? 1, 2, 3, 4, 5, 6, 7. Clearly 8 gaps. 8 gaps is there. So number of arrangements is equals to number of arrangements. Number of arrangements is equals to. Already we know that formula. How many ways? 8 men. 8 men around a circle. How many ways arranging the 8 men around a circle means we know that formula, that is n minus 1 factorial. N minus 1 factorial. So n minus 1 factorial, that means 8 minus 1 factorial into 8 minus 1 factorial into. Again they give one condition, that is such that no 2 men can sit together is. So women are sit the middle of the, that is M1, middle M2 are these gaps. These gaps. How many gaps is there? 1, 2, 3, 4, 5, 6, 7, 8 gaps is there. So women can sit these gaps only. Why? Because they gave one condition: no two women can sit together. No two women can sit together means so women can sit these gaps only. So how many ways? How many ways can sit four women in 8 gaps means already we know that formula, that is 8 NPR, that is 8P4, that is 8P4. How many ways? 4 women in 8 gaps. Arranging them means clearly that is NPR formula. We use that formula, that is clearly 8P4. So 8 minus 1. 8 minus 1 is equal to 7 factorial into 8P4. 7 factorial into 8P4. Okay. This next one, third one. The number of ways in which 6 men and 5 women. 6 men and same as his previous problem. That is the number of ways in which 6 men and 5 women can dine at a round table. If no 2 women or to sit together is given by. No 2 women or can sit together. No 2 women or can sit together. So 6 men, number of men is equals to clearly 6 number of men is equals to how much? 5. So can dine at a round table if no 2 women can dine at a round table. This is can dine at a round table, that is 6 men. Clearly M1, M2, M3, M4, M5, M6. The number of ways in which 6 men and 5 women can dine at a round table if no 2 women are sit together. First of all, number of circle arrangements of 6 men is clearly 6 minus 6 men. How many ways? The number of circular permutations of 6 men around a round table is equals clearly 6 minus 1 factorial. 6 minus 1 factorial. After that, here they give one condition, that is no 2 women are sit together is. No 2 women are sit together is. So women are compulsory sit in only the gaps here, that is. How many gaps here? Clearly 1, 2, 3, 4, 5, 6. How many gaps? 6 gaps. In between these 6 gaps, 5 women can sit here. So, how many ways 5 women, in how many ways 5 women are to fill this 6 gaps means already we have a formula, that is NPR. So, here that is into 6P5. So, number of arrangements is equals to, according to the fundamental principles of counting, number of arrangements is equals to number of ways or arrangements is equals to. Clearly, first of all, we arrange the boys. That means how many ways? Arrange the boys in a round table. That means we have a formula, that is n minus 1 factorial. So we around a circle, the men are arrange them into 6 minus 1 factorial ways. 6 minus 1 factorial. After that, here they gave one condition, that is no 2 women are sit. No 2 women are to sit together is. So women are compulsory sit in the between of these gaps only. So how many gaps here? We have 6 gaps here. So how many ways to fill these 6 gaps? By using 5 women is clearly formula is NPR. How many ways to fill this NR blank places by using, and this is clearly NPR. So here also by using our fundamental principles of counting, that is 6P5. That is equal to 6 minus 1, that is 5 factorial into 5 factorial into 6p5. NPR is nothing but n factorial by n minus r factorial. NPR is equal to what? NPR is equal to n factorial by n minus r factorial. So 6p5 is nothing but 6 factorial by 6 minus 5 factorial. 6 minus 5 factorial means how much? 1 factorial. So we get here 5 factorial into 6 factorial or 6 factorial into 5 factorial. Ways we arrange them 5 men, 6 men and 5 women. No 2 women are sit together in a round table. That is. Next question. The number of ways in which 6 boys and 3 girls. So number of boys is equal to number of boys is equal to clearly 6. Number of girls is equal to number of girls is equal to clearly 3. In the number of ways in which 6 boys and 3 girls can sit around a round table, we want number of circular permutations around a round table, so that we have already one condition that all the girls come together. That means whenever they sit, all the girls are come together. Sit only, they sit, come together means sit together means. So in this condition, these number of girls, how many girls are there? 3 girls. So 3 girls are considered as 1 unit. That is 1 unit. Let us assume that 3 girls are considered as 1 unit. Why? Because in a round table, wherever you sit, 3 girls are compulsory beside only. That means come together. Come together means all 3 girls are sit together. So that's why all 3 girls are considered as only 1 unit. All 3 girls are considered as single unit. So number of units is equal to number of units is equal to here we have 6 units plus 1 unit, total 7 units. So number of boys 6, number of girls 3. They gave one condition that girls come together means all girls are sit together only. Wherever the girls are sit, they seated. So all girls are come together only. That's why number of, let us assume that 3 girls considered as 1 unit. 3 girls considered as single unit. Total units 6 boys 6 units plus 3 girls considered as 1 unit. That is 6 plus 1, total 7 units. Therefore, number of arrangements is equal to number of arrangements or number of ways is equal to total 7 units. 7 units. How many ways? In how many ways are the number of circular permutations of 7 units taken all at a time? Taken 7 at a time is clearly already we know that formula, that is n minus 1 factorial. N minus 1 factorial means 7 minus 1 factorial. 7 minus 1 factorial. But here observe here, 3 number of girls is 3. So 3 girls are also permutated. That means in round table that is here 6 boys, 1, 2, 3, 4, 5, 6 boys, B1, B2, B3, B4, B5 and B6. Here number of girls is 3. 3 are considered as 1 unit. 3 are considered as 1 unit. 3 girls considered as 1 unit. This is 0. So total 1, 2, 3, 4, 5, 6, 7. So 7 things are 7 units. 1, 2, 3, 4, 5, 6, 7. So 3 girls compulsory sit here only. Come together means 3 girls compulsory sit beside only. So 3 girls are sit together only. So that's why in how many ways 3 girls are permutated means 3 girls are permutated here. In how many ways can permutated 3 girls means clearly that is 3 factorial ways. 3 factorial ways 3 girls are permutated. So total 7 units, 7 minus 1 factorial into again 3 in that one unit, girls unit, that is 3 girls are again they permutated. So how many ways? That means this girl sit here or this girl sit here. So how many ways this permutation is? 3 factorial ways. You have to permutate, so 3 factorial by using a fundamental principle of counting. So 7 minus 1 factorial into 3 factorial. That is equal to 7 minus 1 factorial is equal to how much? 6 factorial into 3 factorial. 6 factorial value already we know that is 6 factorial value is 720 into 3 factorial. 3 factorial is equal to how much? 6. So clearly 6 0 0, 6 2 is 12, 6 7 is 42, 42 plus 1 clearly 4302 ways they are sit together. This is next. Yes. Next one, observe here. Next problem. 12 persons are to be arranged. 12 persons are to be arranged to a round table. If two particular persons among them are not be side by side, then the total number of arrangements we want. Then the total number of arrangements. That means, observe here. So, clearly 12 persons, that is person number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total, observe here, 12 persons are to be arranged. 12 persons are to be arranged in a round table. So how many ways 12 persons are arranged in a round table means already we know that formula that is n minus 1 factorial. Clearly 12 minus 1 factorial. So 11 factorial ways we arrange them. But they gave one condition here. That is among them are not be. Among them is two particular persons. Here any two particular persons. For example, P3 and P4. These two particular persons. Any two, that is I take P3 and P4. So P3 and P4, if two particular persons P3 and P4, among them are not be side by side, not at all sit side by side. That means P4 not sit here and here. They sit here any places, but not sit here and here. That is no two among them. If two particular persons among them are not be side by side, then the total number of arrangements we want. So these two persons are not be sit by side. So how many ways to find this? How to find this arrangement? Observe here. Total number of ways is equals to solution. Number of persons is equals to here. Persons is equals to 12 persons. We have 12 persons. Among them two persons are P3 and P4. Consider as one unit. Let two persons are considered as one unit. So we want number of ways, number of arrangements or number of ways, total number of ways we want. How to find this type of questions which total number of ways is equals to the total number of arrangements minus total number of arrangements. Total number of arrangements. That means these total number of arrangements. Total how many ways 12 persons are arranged in a round table means already we know that formula that is n minus 1 factorial. So 12 minus 1 factorial minus here two particular persons are not sit side by side positions. So in this case that is minus two particular persons side by side arrangements. Two particular persons side by side. A total arrangements minus two particular persons side by side arrangements. If you remove it, we get total number of. That is, we want what they ask means the total number of arrangements. So, how many? Clearly, observe here. Total number of arrangements. 12 persons. How many ways to arrange them in a round table means already we know the formula. That is n minus 1 factorial. So, 12 minus 1 factorial. 12 minus 1 factorial minus two particular persons side by side arrangements. Remove that is two particular persons side by side arrangements. So two particular persons, clearly two particular persons considered as one unit. Two particular persons considered as one unit. So total units is equals to two particular persons considered as one unit. So total units is equals to total units is equals to, if you remove 10 units plus two particular persons considered as one unit, that is 10 plus 1, that is equal to 11 units. 11 units. Observe here, two particular persons side by side arrangements we want means, but the two particular persons, these two particular persons considered as one unit. So total number of units is equal to 11 units. So 11 minus 1 factorial into these two particular persons also permutated in how many ways means 2 factorial ways. How many ways? 2 factorial ways. That means here P4 or here P3. So how many ways these two particular persons are arranged them means 2 factorial ways. We want not to be side by side arrangements. Here the two particular persons side by side arrangements. How many it means? 11 minus 1 factorial. If they ask the two particular persons side by side arrangements means clearly the answer is 11 minus 1 factorial into 2 factorial. But here they ask not if two particular persons among them are not be side by side. So total, if you remove total arrangements minus two particular persons side by side arrangement, we get not be side by side arrangement we get. So that's why 12 minus 1 factorial is equals to clearly 12 minus 1 factorial is equals to 11 factorial minus 11 minus 1 factorial is equals to 10 factorial into 2 factorial. 11 factorial, already we know that. n factorial can be written as n minus 1 factorial into n. So that's why 11 factorial can be written as 10 factorial into 11 minus 10 factorial into 2 factorial. So clearly here 10 factorial is common. Take 10 factorial common. 10 factorial comes. Here we get 11 minus 2 factorial is nothing but 2 1. So that is equal to 10 factorial into 11 minus 2 is equal to how much? So 9 into 10 factorial. So number of arrangement not be side by side arrangement, clearly 10 factorial into 9 or 9 into 10 factorial. This is